In this video, we will be learning how to name molecular compounds. This continues our learning objective for writing chemical formulas for compounds and naming chemical compounds. So molecular compounds cannot be named like ionic compounds because we cannot predict the number and quantity of each element that make up the molecule just by knowing which elements are involved in the compound. That's because the same elements, the same pairs of elements, can form different compounds with each other. And so we need a naming scheme that helps identify not only which elements are in there, but also in what quantity are those elements present. So we will only be naming inorganic molecules for now that contain two atoms, two different elements. So generally speaking, when we write our chemical formulas, you want to pick the element that's in the smallest group number first, which is going to be closest to your left-hand side. And if you have two elements that are in the same group, you would pick the one with the greatest period number. So furthest down. And that's the one that would be written first in the chemical formula and the one that would be named first. It's a general rule of thumb that's not like 100% certain. This tells you the list of what order would go where in a chemical formula, like officially, but you can see that the leftmost group number is there. Molecular compounds only contain nonmetal elements, and so you'll never see like lithium or beryllium in a molecular compound. So just boron in group 13 over. Even some of the heavier noble gases do form molecular compounds. Anyway, look at these molecules here. The color codes are off to the side. And try to write out the chemical formulas for the two molecules you see. Unpause the video when you are ready to double check your work. All right, let's go over this. So carbon is in the smallest group number, so that one's going to go first. There's two carbons. Next up would come hydrogen. Hydrogen gets inserted right after nitrogen, but sometimes you'll see hydrogen listed right after the carbon, and then nitrogen listed later. 1, 2, 3, 4, 5, 6 hydrogens, and 1 oxygen. Now for this one, we can see that sulfur is in a smaller group number than fluorine, so sulfur will be listed first. Fluorine is, there's 6 fluorines there, so that's SF6. All right, since we can have the same elements forming multiple different compounds, we're going to need to use prefixes to indicate how many of each element is present. These are the same type of prefixes that were used to indicate the number of water molecules when we were naming our hydrates. So same set of prefixes. Now, generally speaking, you put the prefix before the name of the first element and then a prefix before the name of the second element. The only exception is the mono prefix for the first element. The mono prefix for the first element is never used. As an example of nomenclature that you might be familiar with just from living everyday life, you might know the two compounds carbon dioxide and carbon monoxide. There is no mono prefix here. But that still means that there's one carbon. For the first one, there's 2 oxygens. And here there's only 1 oxygen based on the prefixes. This molecule has 1 nitrogen and 1 oxygen. This has a chemical formula of NO, and so that's nitrogen monoxide. Would you like to hear a joke about nitrogen monoxide? No? Ah. Okay, sorry. Bad jokes. Better in person. You got it. 2 nitrogens here, and then 1 oxygen. So nitrogen comes first in the chemical formula. It also gets named first. We do put a di prefix on it, and monoxide here. So a lot of the prefixes, there's an A in order to, like tetra or hexa, in order to help pronunciation. But if your element starts with a vowel, then that A is dropped off. You will need to include the I's next to words though. Anyway, there's some spelling nuances that you'll have to learn, but it's all to have like good pronunciation. So it should roll off the tongue pretty well. Just try to say it out loud to see if it sounds good. NO2. So 1 nitrogen, 2 oxygens. So that's nitrogen dioxide. No mono prefix here because there's only 1 nitrogen. All right, go ahead and pause the video and try to fill in the missing areas of the table in your notebook. Unpause the video when you're ready to continue and double check your work. All right, let's go over this. This has nitrogen listed first, and so that is 2 nitrogen, so that's di-nitrogen. No suffix change there. That's pentoxide. The second word does get an "ide" ending. This is carbon disulfide, so that means 1 carbon, and then di means 2, so 2 sulfurs. This one is sulfur, hexa, because there's 6 fluorines, 6 fluorines. Fluoride. Now I have 2 arsenic, so that's diarsenic, and then 3 seleniums, triselenide. Now I have 3 silicons, so that's Si with a subscript 3. That's tetranitride, so that's nitrogen with a subscript of 4. These are molecular compounds that contain hydrogen. These molecular compounds containing hydrogen do not follow the remaining nomenclature rules. We have our set of nomenclature for acids, and then there's these compounds. So these compounds are not acids, and so they can't follow our acid nomenclature rules. They are just regular molecular compounds. So you just have to kind of know their names. Water is H2O. It's not called dihydrogen monoxide, but there is some pretty funny stuff on the internet about dihydrogen monoxide. that you can look up just for fun. And then there's ammonia, which is NH3. That's the neutral form of ammonium. And ammonia is sold as a cleaner. So you can go to Walmart and buy a giant gallon jug of ammonia if you wanted to. And then methane is CH4. That's the primary component of natural gas. And so that's CH4. And that's an organic. And that does follow organic nomenclature rules, which we have not covered yet. So that concludes our video on naming molecular compounds.